Hello students, this is the Digital Knowledge Irshad Academy with a new video of black box equivalent of operational amplifier. Before going to explanation, subscribe my channel and press bell icon for next video. Looking at the circuit explanation, we have black box equivalent of operational amplifier. V input is applied between positive terminal and ground, and it is across ZIC, as ZIC is a common mode input impedance. Voltage applied here will be amplified by gain times the operational amplifier, but the phase will not be inverted. V input 2 is applied between negative terminal and ground. This is called V input 2 as the sign indicates, and it is applied across this ZIC, and the output will be amplified, but the phase will be inverted by 180 degree. V input applied here is across ZID. ZI is a common mode differential impedance. See that the V input is equal to V input 1 minus V input 2. This indicates that when both the inputs are applied, they are applied between this terminal and this terminal. The amplifier is working in a differential mode, and amplifier will amplify the difference of the two voltages, or it will amplify the algebraic difference of these two voltages. ZIC, common mode impedance, is across each terminal to ground, and it is very high. It has a high value, and it is from 1 mega ohm to 100 mega ohm. ZID is from 10 kilo ohms to 100 kilo ohms as a differential mode input impedance. ZO is the output impedance, and it is from 100 to 150 ohms. It's not in kilo ohms nor in mega ohms, it is just in ohms. ZL is the output impedance. V output is taken across ZL, and this, as we know, is called output control generator. A V input means the V input is amplified by gain of the operational amplifier, and this can be written as V naught can be written as A V input 1 minus V input 2, and this indicates that the operational amplifier is working in a differential mode. Let us recall voltage output formula. We know that is equal to V input 1, that we have already learned. That is the ZO plus ZL into ZL. This can be written as ZL over ZO plus ZL into A V input 1 minus V input 2. Same formula is rearranged. ZO being small can be neglected because it is in ohms. ZL cancels with this ZL, and finally we have V out is equal to A into V input 1 minus V input 2. What does this mean? Means the difference of the two input voltages is amplified by A times and we get in the output. Now we have three options, supposition. In the first case, we suppose that V input 2 is 0. This is first case. V naught is equal to a V input 1 minus V input 2 is 0, and this is nothing but a V input 1, and from here we see that the V input 1 voltage applied between positive terminal and ground. V input 1 is applied between positive terminal and ground. It will be amplified by A times and we get in the output, and then the amplifier is working as a non-inverting. Why? Because the output polarity is not inverted. Second case, we suppose V input 1 is equal to 0. Let us rewrite the formula. V naught is equal to A V input 1 minus V input 2. By putting the value of V input 1 here is 0, V input 2 to A, and this can be written as minus A V input 2 is our V naught. From the formula we see that V input 2, this is V input 2, is applied between negative terminal and ground, and we already knew that this will be amplified in the output, but the phase will be inverted by 180 degree. So we say that amplifier is working as inverting amplifier. Output is amplified and inverted in phase. This is the first case we supposed. This is the second case of supposition. Thirdly, we suppose that V input 1 is 0 and V input 2 is 0. Writing the formula, V naught is equal to A into V input 1 minus V input 2. This is 0, this is 0. This is the third case. V naught becomes 0. This is the important case. See that when both inputs are 0, the V naught is 0. V input 1 is 0, V input 2 is 0, and both the inputs are 0, 0. The V naught should be 0, but this is mathematically this is true. The equation 3 says that when both the inputs are 0, 0, the output should be 0. But in practice, practically, we do not get 0 voltage. There is a small amount of voltage available in the output due to unequal behavior of transistors in the operational amplifiers. They have unmatched characteristics. They are not perfectly balanced. As such, they produce small amount of voltage in the output despite being both inputs 0, 0. This small amount of voltage in the output is called error voltage, which is not desirable, and to overcome this voltage we apply error voltage produced when both inputs are 0, and to neutralize this error voltage we apply external DC voltage to neutralize this voltage, and that is called DC Off Set voltage. Remember that this